So we're going to be starting Unit 3, and in this unit we're going to be working with linear systems. So to start, we're just going to define what a linear system is, and a linear system is defined as two or more equations interacting on the coordinate grid. So we've been working with developing equations and working with the equations to graph them, but now we're going to be working with two or more equations. So since we will continue to work with linear relations, we're going to need some of the skills that we just did in the last unit. So for example, we have to be able to graph these equations. So both of these equations are in slope y-intercept form, which is usually the easiest form to work with. So we're going to start by labeling the slope, and then we're going to label the y-intercept. So in this case, for question A, some of you guys may prefer to identify the slope first, or some of you may do the y-intercept or starting value first, but I'm just going to start by doing the slope, because the slope is the number that is always in front of the x. But there is no number there, and when there is no number in front of the x, make sure that you know that it's a 1. If I take a look at the starting value, also called the y-intercept, we know that is the other number, and the other number in this case is -1. We'll go ahead and do the same thing for question B. There's a little second B here, you can just scratch it out. So from here, you can go ahead and label that m is equal to the -4. Remember, there's no x when you label the slope, it's just the m value. And the b value in this case is 1. So be careful, the b values are very similar. One of them is negative, one of them is positive. So we're just going to go ahead and graph this. For question A, I'm going to use a starting value of -1. So that means that it's a starting value on my y-axis. You need to remember that that's on your y-axis. And to graph more coordinates, you need to use your slope, which is your rise over your run. But in this case, we have a little problem because we only have a rise. Well, this is where you have to remember to create the run. If the run isn't there, we know it's also a 1. So since both numbers are positive, we're going to rise up 1, and we're going to go to the right 1. So you'll see that if I go up 1 to the right 1, it creates a nice line over here, and I'm going to go about that far. Now, to go the other side, instead of going up 1 to the right 1, we're going to go down 1 to the left 1. And from here, you need to use a ruler and make a nice straight line so that you can put your arrows at the end. So we're just going to go ahead and do that. Oop, that didn't go quite through my coordinates, but I don't want to erase it at this point. So there's question A. So I'm just going to label question A. Now for question B, I'm going to go ahead and actually change the color. Now if some of you guys have different color, that's useful to label each equation. But if you don't, it's not really that big of a deal. You just need to make sure that you label your equations just a bit better. So we're going to start this graph at +1 on the y-axis. Oops. Oh, it deleted it. So we're going to start at +1. And this graph is the pink graph. And then to create more coordinates, you need to use your slope, which is the rise over the run. Now, since the rise is -4, that means we'll be going down 4. But we're missing a run, so we need to make sure we put this over 1. So if we go down 4 to the right 1, this is what the graph is going to start looking like. I can do that one more time. And those are coordinates to the right of the starting value. Now we're going to draw some coordinates to the left. So instead of rising down 4, we're going to rise up 4. And instead of going to the right 1, we're going to go to the left 1. And that should create a line that is easy-ish to graph. So this should be fresh in your memory because we just finished this unit. And again, if you don't have different colors, please make sure to label your line with a B here. So When you take a look at these two lines, that's great to know how to graph them, but what do you do with two lines now? We're so used to drawing one line that graphing two lines should also there should be something that we're looking for. So to solve a linear system means to find the point of intersection. And the point of intersection is the shared point where the two lines cross. So as you can see, these two lines cross right there. And that's what we call a point of intersection. If you think about an intersection, when you go driving, an intersection is where two roads cross. And in this case, it's kind of the same thing. You can picture it as two roads crossing. And that's the point that we'll be interested in. But is one point of intersection the only option for a system of linear equations? So for example, in our previous example, yeah, they did cross. But is that always going to happen? So we're going to take a look here at what actually is happening. In the situation that we just saw, we're just going to kind of sketch two possibilities here. So you can just kind of sketch this. It doesn't have to be specific. I just want you to draw one line in one color, and then I'll draw the other line in a different color. So in this case here, again, doesn't need to be specific. We're just going to make sure that both of these lines cross. Okay. So there's line A and there's line B. Now, as you notice, these two lines do cross. So if I circle this part, that's where the point of intersection is. So I'd like you to make sure that you write that down so that you understand what a point of intersection actually is. Okay, so as we write that down, we have to investigate other things that are happening. So if we take a look at these two lines, I want you to recognize that one of these slopes is going down. One slope should be negative, and the other slope should be positive because the line is rising up. So in this case, both slopes are different. And you need to know that when you look at lines, that the slopes are different. And in a second, we'll do an example when the slopes are the same so that you can see what that looks like. In this example as well, if you take a look at the y-intercepts, well, there's one y-intercept happening here, and there's one y-intercept happening right in here. So both of those y-intercepts are actually also very different. So if the slopes are different and the y-intercepts are different, this means there is only one point. I'm going to shorten point of intersection. There's only one point of intersection. Okay? So that will happen when you have different slopes and when you have different y-intercepts. So it might be easier to see it on a graph rather than seeing it as an equation, but those are things that we need to start analyzing very, very well. So let's draw another set of lines. So this set of lines, we're going to make one going this way with the arrows, and line B, I'm going to make it go this way. Now this one needs to be drawn a little bit more specifically because these two lines actually don't ever cross. And because these two lines never cross, this means something very specific for the slopes. They're going in the same direction, which means your rise and the run is exactly the same for both lines. So we're going to write that the slopes are the same. That doesn't mean that your y-intercepts are the same, because if you take a look and analyze this graph, you could tell that the y-intercepts are actually quite different. So looking at this, we're going to have to write down that these are different. And if you take a look at this, you could see quite clearly that these lines don't cross ever. So in this situation, there is no points of intersection, or 0 points of intersection. So it is possible that your lines won't ever cross, and that will be possible when your slopes are the same. And then there's one more situation. So I'm going to go ahead and draw two lines. Okay, so there's the first line. That could be line A. And then I'm going to go ahead and draw line B. So if I wasn't using this program and I was using technology, you would notice that both the blue line and the pink line overlap. But with technology, you can't really see that because they don't necessarily use color. So in this case, you have to realize that there's actually two lines here. There's line B and there's line A. They're just a little bit harder to see because they're overlapping. And when they're overlapping, that means they're the exact same line, which means that the slopes will be the same. And this is the only situation where the y-intercepts are also the same. So in this example, there's an infinite amount of points of intersections. So infinite amount of points of intersection. Everywhere you look on this line, there's a point of intersection because both graphs are overlapping. Okay, so there are three ways that a linear system can interact on the coordinate plane. If the slopes are different, and we go back up here, that means that there will be one point of intersection. So we already kind of discussed. We're just going to rewrite it for your notes. If the slopes are the same, but the y-intercepts are different, then there will be no points of intersection, or 0 points of intersection. And then finally, we have the last situation, which would happen here. If the slopes are the same and the y-intercepts are the same, then there will be an infinite number of points of intersection, which means there's an infinite amount. Like there's just so many that you can't really name how many there are. There's just so many of them. So to practice, we're going to do an example together, and then you're going to have to do the work. So determine the number of points of intersection in the following systems of linear equations. Then graph both lines to check your answer. So you can do a prediction first if you'd like, but as you notice, this equation is in y equals mx plus b, but this one is in standard form. And I know that most of you guys may struggle with standard form a little bit, but this is a good time to practice it. So when it's in standard form, we want to convert it. We want to change it to y equals mx plus b form. So I'm going to put a box around the y. And when I put the box around something, it means I want to cancel whatever is around it. So I want to cancel out the minus 2x. And to do that, I have to do plus 2x. Not just plus 2, there's an x there. To cancel out the plus 4, we're going to do minus 4 on both sides. So that cancels out and that cancels out. And we now have y equals 0 plus 2x minus 4. We don't really need the 0 there, so we're just going to rewrite that this is 2x minus 4. You can predict this just by analyzing what's happening. First of all, the slopes are completely different, and your y-intercepts are completely different. So go ahead and make a prediction. Do you think there'll be 1, 0, or an infinite amount? So take a second to do that. And hopefully you'll have written it down by now. So I can't predict because I know how to do this. So we're just going to go ahead to graph both lines, and then we're going to check your prediction. So the slope in line A is 2, since that's the number with the x. And the y-intercept, or the starting point, is negative 4. So let's go to negative 4, draw a dot, and don't forget that the slope needs to be a rise over a run. And in this case, we have a rise, but we need to create the run. So we're going to put over 1. We're going to go up 2 to the right 1. And then we're going to keep doing that until we have enough coordinates to the right. And we're going to want to draw some to the left of the starting point. So instead of going up 2, we're going to go down 2 and then to the left. So once you're doing that, or done doing that, you can put your line through it. A nice straight line, and call that A. Once you're done with A, you can go ahead and graph with B. So the slope of B is negative 1 over 3. Now don't panic because it's a fraction. It actually makes it a little bit easier. Now notice I took the negative that was in the middle and I moved it to the top. Now my B value is equal to positive 3.